Fundamentals of Machine Learning (ML). In this particular section, we will dive into the core concepts of machine learning, exploring different types of learning, key algorithms, and process of building and evaluating ML models. Understanding these fundamentals will be crucial as you begin working with machine learning services on AWS. The topics that we will cover include supervised versus unsupervised learning, key machine learning algorithms, training versus inference in machine learning, introduction to model evaluation and performance, and finally, we'll do a hands on lab. We'll be training a simple machine learning model. So let's get started. Hands on lab training a simple machine learning model using AWS SageMaker. In this hands on lab, you'll gain practical experience by training a simple machine learning model using Amazon SageMaker. The goal is to guide you through the complete machine learning pipeline, including data preprocessing, model training, and evaluation. This lab is ideal for beginners looking to get hands on experience with machine learning and AWS's managed services. Our objective will be to train a binary classification model using AWS SageMaker to predict whether an email is spam or not. We'll learn how to set up SageMaker environment, import data, pre-process the data, train a model, and evaluate the model. The prerequisites for this particular lab includes AWS account. If you don't already have one, sign up for a free tier AWS account and AWS SageMaker Studio setup. SageMaker Studio is a web-based IDE for data science and machine learning tasks. Set it up from the AWS Management Console. And if you don't have it, we'll do that in the first step anyways. The steps that we will follow is first, we'll set up the SageMaker Studio, where we will launch SageMaker Studio and then create a SageMaker notebook. Then we're going to go into preparing the data. Then we'll train the model, and finally we will evaluate the model. So let's jump into hands-on. So step 1 is to set up SageMaker Studio, where we will launch the SageMaker Studio and create a SageMaker notebook. So for that, let's go into our AWS Management Console. If you have not logged in, I would say log into your AWS Management Console, and once you get there, search for SageMaker and Amazon SageMaker. Now inside SageMaker, it will take you to this first page where it will say build, train, and deploy machine learning models at scale, and it will also show you how it works. It's going to give you a step-by-step guide on how to do this, whatever we are doing right now. It also has an introduction video about it, so you can follow along that. You can go to get started and then go from there. So these are all the different steps that you'll follow, but I'm going to go ahead and walk you through this settings myself. So first, let's go to domains, and I'm going to create a domain. Let's say setup for a single user, not for organizations. If you're an organization, you'll probably set up for organizations, but if what we are doing right now is for a single user, so we're going to do that. It's going to create my domain, and once the domain is created, I'm going to check up everything. It looks good. Now this is the name of the domain, where I can just look at the last three numbers, 383, and remember that. Go back to my Amazon SageMaker. It's saying SageMaker is being set up, so I'll give it a few minutes. So once my setup is done, it will probably, I can go back to domains and look at it that it's saying pending here. So it's still running through it. I'll give it a few more seconds and come back to this. So once it's completed, it's going to say in service. So I'm going to go back into my domain here and then inside user profiles and create a user. Going to keep the names, everything default. Make sure that the right Amazon SageMaker execution role is selected. Next, and then here is where I'm going to go ahead and configure the applications, customize Studio UI, data and storage settings, and review and create. So I will pick the new one instead of classic, whatever is default. Jupyter Lab is what I need. I'm going to keep everything that is there as default and press next. Now it depends on how you want to use your Studio UI. You can define your UI. I'm going to just use the Jupyter Lab, nothing else, but I'll keep everything as it is and go to the next section. Inherit settings from domain, that's perfect. Next, and finally I'll say submit and create. So this created my user profile on my domain that I've created. So now I can go to my user profile here and launch this user profile. So I can say open studio. So that was our first step, launch SageMaker Studio. Now we are going to create a SageMaker notebook. It's going to give you a tour. If you want to look at the steps, all the different elements in your SageMaker Studio, you can go through that, but I'm going to skip it and I'm going to directly jump into my Jupyter lab. Let me close this here. And on the top of the page, I'm going to say create Jupyter lab space. I'm going to give it a name. I'm going to say AI hands-on, keep it private and create the space. I'm going to keep everything as default, whatever instance, whatever image it comes with, and I'm going to say run the space. It's going to say error because you'll have to wait a little bit. I think I've pressed it a little quickly. So I'll wait for the space to be created and then press run space. So once it's done, I'm going to say open Jupyter Lab. It's going to open in a new tab. And there you go, our Jupyter notebook is available to use. I am going to select Python 3 for our tutorial. So that kind of takes care of our first step, where we have set up the SageMaker Studio. We launched SageMaker Studio and we created a SageMaker notebook. So next step is preparing the data. So in this particular lab, we'll use the pre-prepared data set for training a binary classification model to predict whether an email is spam. The data set will consist of various features such as word counts and a label for spam or not spam. Now, where will we get this data set? So we'll download this data set from spam-based data. It's called spam-based data set from the UCI machine learning repository. So you can just Google for spam-based data set CSV. You get the UCI machine learning here, but I'm going to go to Kaggle and download my CSV from there. You can do the same thing. Once it's downloaded, I'm going to close this, and so I'm going to open my desktop, and that's where my download is. I'm going to take this file and move it into my notebook here. So you can also upload it, but I just dragged and dropped. It's much more easier. And then inside my notebook, I can start writing the code for this. Now this particular spam-based data set from the UCI machine learning repository contains around 4,600 email records with over 50 features extracted from text of each email. So you can look through that. I'm going to say no here. And then next what we did was we uploaded the data to the SageMaker Studio. And finally, we're going to go and load and explore the data here. So let's go ahead and write some code. Import pandas as PD. Next. So this, what am I doing here? So this imports the pandas library, which is used for data manipulation and analysis, especially for handling structured data set. Pandas provides convenient way to load and work with tabular data. So that's why we are doing that. Now next step is I'm going to say data equal to PD dot read underscore CSV. I'm going to give the name of the file, which is spambase.csv. So here what I'm doing is this line, let me remove this. This line loads the CSV file named spam-based using pandas. So that's the file here. The data set is assumed to be a spam email data set where each row represents an email and its feature like word counts and label indicating whether it's spam or not. The read CSV function reads the CSV file and converts it into pandas data frame. So let's run this. You can press option enter, or you can just press play on the top. It will run that and you got my data set. I can also do one more step here, which is print the data set, not the entire data set because it's too much to print here. So I'm going to just say head, which is the first few rows, and run this code. Now if you see here, it's going to print all my rows, and if you see the last column is spam, which tells if the email is spam or not. So it has all that information here, and then based on that information it tells if it's spam or not. So that's how the data was collected, and that's the data that we will be using. Now next thing is we will be doing the data pre-processing, where we will be splitting the data into features x and labels, features which are x and labels with the variable y. The label for whether the email is spam will typically be in the last column, which we have seen here. So what I'm going to do here in this particular step is say x equal to data dot iloc colon comma colon minus 1 and for y I'm going to say, let me make it a little bit bigger so it's clear. Say data dot iloc colon comma minus 1. So the labels. So what I'm doing here is this line splits the data into features x and labels y. Now iloc colon comma colon minus 1 uses pandas to select all rows, which is colon, and all columns except the last one. That's why I said colon minus 1 over here. The columns except the last one are treated as input features. So all these are input. This is pretty much what I want to kind of figure out or predict whether it's spam or not. So that's why that's my training data. Now, whereas y data iloc colon minus 1, this selects the last column of the data set minus 1 as the label y. In this case, the last column contains the labels spam, in this case spam or not spam, where a binary classification is expected. That's why it's 1 for spam and 0 for not spam. So we have our training data set and we have the results which are labels, which is spam. Next step is splitting the data into training and test sets. So what I'm going to do here is first I'll say from sklearn dot model underscore selection import train test split. So I'm importing something here. What is that? From sklearn.model selection import train test split. This imports the train test split function from the sklearn model selection module. This function is used to split the data set into training and testing sets. So what do we do for with that? What I'm going to do is I'm going to say x underscore train comma y x underscore test comma y underscore train comma y underscore test equal to train underscore test split, pass it x y the labels, test underscore size equal to 0.2, and finally random underscore state equal to 42. So this splits the data into training and testing sets. X and Y are split into X train, X test, Y train, and Y test. Test size 0.2 means 20% of the data is reserved for testing and 80% is used for training. Whereas the random state equal to 42 ensures that the split is reproducible. It controls the randomness of the shuffling process. So you'll get the same split every time you run this particular code. So I'm going to go ahead and run this code. I'm getting a name. X is not defined because I did not run this code before. So I'll run this first. Make sure that runs. That is good. Now I'll run this again and it will work. And it worked. So the next step is, now that we have split the data, next step is training the model. So we have already prepared the data. So our data is available. Now the next step is to train the model. So in this step, you'll use a pre-built algorithm in SageMaker to train your machine learning model. For this lab, we'll use the logistic regression algorithm, which is suitable for binary classification tasks like spam detection. So let's go ahead and use SageMaker's built-in algorithm. The algorithm we'll use is called linear learner algorithm for logistic regression. So for that, I'm going to go back and first import SageMaker. That's good. Next I will, from SageMaker, I will import the algorithm which is linear learner. Again, to go over this, the import SageMaker imports the SageMaker Python SDK, which provides tools to train, deploy, and manage machine learning models on AWS. That's what SageMaker does. Next is from SageMaker import Linear learner, which imports the linear learner class from SageMaker. Linear learner is an algorithm provided by SageMaker for solving supervised learning problems like binary classification or regression, which is good for this particular lab. Now let's go ahead and in the same tab, same cell, let's create SageMaker underscore session SageMaker dot session class. So this initializes a SageMaker session. The session object manages interactions with AWS services such as Amazon S3 used to store data sets and models and other SageMaker components. Next, we will do role equal to SageMaker dot get execution. If you remember, we created the execution role, so that's what I'm doing. So this retrieves the get rid of that. This retrieves the AWS Identity and Access Management IAM role that SageMaker needs to perform tasks like training and accessing resources. The role needs appropriate permission to read and write data to S3, interact with SageMaker services, etc. That's why we had selected when we created it the right SageMaker execution role when building it. So next step is to initialize the linear learner model for binary classification. So I'm going to say linear equal to linear learner, call that class. Inside that I'll pass role equal to uh, the role that we got. Next I need let me bring it a little above, and then instance count is the next parameter that I need. So I can say instance count equal to 1 is what I want to use. I'm going to say instance underscore type, the type of instance that I want to use. In this particular case, I'll use ml dot m4 dot extra large, and then I need the predictor type. I'm going to say predictor underscore type, which is somewhere here, predictor type, make sure the spelling is right, equal to, in this case I need binary classifier. So to go through it one more time, what I'm doing is this initializes the linear learner algorithm, which is designed for supervised learning tasks such as binary classification and regression. The algorithm will be trained using data we prepared. So that's why the role equal to role specifies the IAM role that SageMaker will use during the training job. The instance count equal to 1 is the number of compute instances to use for training. Here we are using a single instance. For the instance type, I'm saying ml.m4.xlarge specifies the type of instance to use for training. In this case, we are using this instance, which is suitable for medium scale machine learning tasks. And finally, the predictor type binary classification, where we have to specify that we are solving a binary classification problem. Now, predicting whether an email is spam or not in this particular case. So, I'm going to go ahead and run this. So, that is complete. Now, the next part is creating the record set for SageMaker. But before doing that, the problem is the data that we have is in float 64 and we have to convert that into float 32. So what we are going to do is we are going to say x underscore train underscore float 32 equal to, we're going to convert the data that we have train as type, because SageMaker library doesn't understand float 64. So we have to do this one extra step for this 32. That's perfect. Now I have to do this 4 times, and the next one was x test is what I'll create, where I'll take x test and convert it. Next one is y train, so I'm going to take that y train, and then finally y test. Make sure all of them are converted. Perfect. I'm going to run this. Nope, I think I forgot to do this again. Run it again, because if you use the same one, it might cause problem. So X-train, X-train, X-test can make sure that you check it one more time. So this converts the training features of all these to float 32 format. SageMaker expects the training data to be in float 32 format, so we need to ensure all numeric values are converted accordingly. As type is the pandas function that converts the data type of a column. So that is good. Next step is to convert the data into a format suitable for SageMaker. So for that, I'm going to create train records equal to linear dot record underscore set, and to this guy I will pass that x underscore train underscore float 32 which I've created, and labels equal to y underscore train underscore float 32. Of course we have to use the values from them dot values. Make sure that you have that in place, so that takes care of that. Make sure, yes. And then now for my this is my training records. Now next is test records, so I'm going to say test underscore records equal to almost same function, linear dot record underscore set, but instead of x uh, train we'll use x test underscore float 32 dot values, okay, comma labels equal to y underscore test underscore float 32 dot values. So I hope you're following along, and let's run this. So what this does in short is it converts the training data and labels into a record set format, which is the format SageMaker's built-in algorithm expect for training. The record set function transforms the numpy array into a record set, which is passed to the SageMaker algorithm for training. So now, which means the next step is to train linear dot fit, and I'm going to pass the training records to it. Okay, let's move it to the top and run it. So this will take some time. It will give you some info warnings about what we are doing, but you can ignore that as long as they're info and not error. And it's starting the training job. It's going to take some time, so I'm going to leave it here and come back in a few seconds. So I'm going to pause it. So after a little bit time, so if you see, it took around a couple of minutes here. It says starting the training job, preparing the instances for training, then downloading the training image, and training image download completed, and then it says training in progress, and then did the training with all the data. As you can see here, it went through everything and trained the model with the data set that we provided. I'm going to scroll all the way down. At the bottom it says uploading generated training model completed, training job completed, training seconds, how much time it took to train, and how much it's going to cost me. It's 139 seconds is what's going to cost me. So that kind of completes our training the model exercise. Now finally we'll evaluate the model. Go back to that. In the same notebook we can do that. So what I'm going to do here is after this model is trained, it's time to evaluate its performance using the test set. So first step is deploy the model for inference. So to make predictions, you can deploy the trained model to an endpoint. This allows you to send new data to model for inference. So I'm going to say predictor equal to linear dot deploy initial underscore instance underscore count equal to 1, and then instance type that I want to evaluate is ml dot m4 dot extra large. I'm going to use the same medium sized. Perfect. So this will deploy the model. So I'm going to say enter, give me some info, and it's going to create stuff. And while it's doing this, it's going to take some time. So I'm going to do run the predictions on that. So I'm going to say predictions equal to, I'll come to know when it's done when the star is gone. So I'm not going to run this one, but I'm going to still write it. prediction dot predict, and inside that I'm going to pass x underscore test underscore float 32 dot value. So I'm going to pass the testing data to it. I'm going to create one more cell for the next step where I'm going to evaluate the model performance while it's still running. I'm not running this because this is not completed. It will give me an error if I run this before that. But next one is evaluating the model performance. Now in this particular case, we will calculate key metrics such as accuracy, precision, recall, and F1 score to assess how well the model performs on the test data. So for that, I need some libraries. I'm going to say from sklearn dot metrics import accuracy underscore score. I need that. I need precision, as I mentioned. Those are the main parameters. Precision score. Next, I need the recall score, and then finally the F1 score. So these are the ones that I'll evaluate it for. Next thing that I want to do is I want to convert the SageMaker predictions into primary format. So I'm going to say predicted labels equal to int. I want to convert to int whatever it's giving me in pred dot label inside my predicted underscore label dot, make sure it's float under 32 underscore tensor dot values of 0, close that, for pred in predictions. So let's look at it properly. I have the from pred in predictions, I'm getting the pred label, predicted values, float numbers. Perfect. So that should work. Next thing that I want to do is, let me go next line. Let's make it a little bigger. Next thing that I want to do is I want to calculate that accuracy, precision, recall, and F1 score. So for that, I'll say first accuracy equal to accuracy underscore score, and for that I'll pass y underscore test underscore float 32. If you remember, we created those. And what are the predicted labels? So that will give me the accuracy. The next thing that I need to do is precision equal to precision, come on, type it out, okay, underscore score, and inside that I'll pass same thing. These are two things that I need. Next is recall, and then is F1. So I'm going to write both of them here. And for this, I will use recall score. And inside that, you guessed it right, I'm going to pass this. Same for this. I'm going to say F1 underscore score. And inside that, I'll pass the same y test and predicted labels. And now I need to print them out. So I am going to say, as you want to see it, and also as you see here on the top above, you'll see that this cell is completed executing. So I can run this cell. That also got completed. So this one. So now if you want to see the values, I am going to say print f accuracy is accuracy from above, this one. Let's make sure it's right. See, perfect. I'm gonna close this out, and I'm going to copy this 1, 2, 3, and 4 times. Next one is precision, next one is recall, and next one is F1 score. So I'm going to say F1 score, recall, and precision. Perfect. So I'm going to run this now. And here you go, you have the value. Accuracy is 0.9, which is pretty good. 90%, precision is 91%, recall is 86%, F1 score is 88%. So it came out pretty amazing. Now if you want to create the confusion metrics in this particular, where you can visualize the confusion metrics to see how well the model classifies spam and non-spam email, what we can do is, we can, here below it, I can get some, let me go through in details for this of how to create a confusion matrix. From metrics, import confusion underscore matrix, that's what I need. Next thing that I need is import cbon. Actually I'm gonna remove this. First install cbon library because that doesn't come by default, and I'm gonna say as SNS. And the last one that I need is matplotlib.py plot as plt. So what I'm doing here is, I am from sklearn metrics, uh, I'm importing the confusion metrics. The confusion metrics function uh, is a table used to evaluate the performance of a classification algorithm. It provides detailed insights into how well the model predicts true positive, true negative, false positive, and false negative instances, especially useful for binary and multi-class classification tasks. That's why we are using this here. Now, Seaborn is a library which is a powerful Python visualization library built on top of Matplotlib. It provides a high-level interface for creating attractive and informative statistical graphics, making it easier to visualize complex data like confusion matrices in this particular case. So I'm going to go ahead and first run this. So I have the Seaborn library. And then finally the matplotlib.py plot as plot, that is a comprehensive library for creating static, animated, and interactive visualizations in Python, and we'll use that quite a lot in future also. Here it's used to display the confusion matrix plot created by Seaborn. So let's go ahead in the next step. Let's get the confusion matrix. So I'm going to say cm confusion matrix equal to confusion matrix, and inside that I'll pass my data, which is y test underscore float 32, and then pass my predicted labels. Perfect. So this line computes the confusion matrix for the model's prediction. The confusion matrix function compares the actual labels, which is the y test underscore float 32, with the predicted labels from the model, and returns a matrix showing the counts of true positives, true negatives, false positives, and false negatives. So that's what we are doing here. And next step is to plot the confusion matrix. To do that, SNS, which is Seaborn, heat map is what I'm going to do, use CM and annotate equal to true, FMT equal to D. So this line creates a heat map visualization of the confusion matrix using Seaborn's heat map function. The CM in this particular case is the confusion matrix from above. Annotate equal to true. This option ensures that the actual numbers, counts of TN, FP, FN, TP, which is the true negatives, false positives, all that, are displayed in each cell of the heat map. And FMTD, this formats the annotation numbers as integers, D for decimal. In this particular case, since confusion matrix contains count data, whole numbers, we want to display the numbers as integers. So that's what this does. Next we have plot dot x label, as we're just giving labels to the plot. One is prediction or predicted, and the next one is for the y, plot dot y label is actual, and then I'll say plot dot show to display it. So this is probably self-explanatory. I don't have to go through that, but let's see. I think I have some spelling mistake here. There you go. Run it again. Oh, I did it twice. Okay, looks like it. I'm gonna run it again. And there you go, our confusion matrix is created. Our actual is here on the y-axis, and x-axis is predicted, and it has my false positives, false negatives, false true positives, and true negatives. So they are all being displayed in this particular graph, as you can see. And that kind of concludes our hands-on, where we have trained a simple machine learning model using AWS SageMaker, and also looked at how it works with the training model and displayed a confusion matrix outside. So I hope it helps. If you have any questions, let me know. So congratulations on completing the lab. If you have any questions, do let me know. But just to do a wrap up, what we have covered here is we have set up AWS SageMaker Studio and prepared your data for machine learning. We have trained a simple binary classification model using SageMaker's linear learner algorithm, and we evaluated the performance of your model using accuracy, precision, recall, and F1 score metrics. Some of the key takeaways that I probably want to talk about is you learned how to set up and use Amazon SageMaker for typical machine learning pipeline, from data preparation and model training to evaluation. You gained hands-on experience using built-in machine learning algorithms in a cloud-based environment. Now, this lab introduced basics of training and deploying machine learning models using AWS SageMaker. It prepared you for the more advanced machine learning task, which we will be covering in the next sections.